All right, let's try that again. Chapter 1, Section 2 is functions. Again, we're going to continue. So yesterday we talked about how to identify if something was a function. We said if we're looking at coordinate points, the x can't repeat with a different y. We said if we're looking at equations, the y couldn't be raised to an even power or in the square root. In the absolute value. And then we talked about how to evaluate a function. We said what happens when we want to set it equal to 0. And then we had one where we wanted to see where they would intersect. So we left off at domain, okay? And so here's a domain review. Domain of a function is all real numbers. So its initial value is all real numbers unless one of these three cases occur. If there's a variable in the denominator, and if that does occur, then we set the denominator not equal to 0. And let's think about why that happens. What happens if my denominator is 0? It's undefined, okay? We can't have something that's undefined, so that's why we restrict it. The second case would be if there's a variable under a square root. And in that scenario, we set the expression under the root greater than or equal to 0. Let's think about why we do that. What happens if there's a number that is less than 0 under a square root? It's an imaginary number, right? Those i's we haven't gotten to yet, but those are not real numbers. Those are not values that would show up on a graph. So those also restrict our domain. And the third is the combination of the two. There's a variable under a square root in the denominator, and now we kind of put both these things together. We set the expression under the root greater than 0 because it has to be positive, but it can no longer be 0 because it's in the bottom. We will write these answers in interval notation. So if you don't remember interval notation, you never learned it, whatever it was, that is one of the topics that's on the prereq list. At the page, it's at the top of your module that says like things I should know by now, okay? So feel free to review it because I won't teach it to you from scratch. We'll review it, but we won't teach it to you from scratch. But like, let's say we were to say, because it's not going to show up in the examples, but let's say my function was just like x squared plus 3x. In that example, is there a variable in the denominator? No. Is there a variable under square root? No. Is there a variable under square root in the denominator? No. So what would be the domain of this function? All real numbers. And the way we display all real numbers in interval notation is negative infinity to positive infinity. So interval notation takes your limitations and it's instead of saying what x can't be, it says what x can be. If it's all real numbers, then x can be anything from negative infinity to positive infinity. I think there's a shortcut key in your WebAssign. I think it's I and F. Like if you type that, I think infinity shows up. Otherwise, you go to the little shortcut menu, special symbols, and you're going to have to tap that infinity every time you need to use it. Anybody still coming down? Okay. So these questions will look like this. It'll say find the domain of the function. And we look at each one. We go to A. What's happening in A that I need to restrict? There's a variable in the denominator. I'm not worried about the one in the top because if 0's in the top, what's your answer? That's a real number, right? 0 is a real number. We can graph 0. So I ignore the numerator. I'm just focused on the denominator. This cannot equal 0, which means that x cannot equal -1. Which means that if I put this in interval notation, I'm saying x can be all numbers except -1, which means it can be from negative infinity up to -1, and it gets a parentheses. A bracket means it can include that number. A parentheses means it can't. And then it's also from -1 to positive infinity. And to separate these out, we put a U between for union, which means it can come from either set. That is not your lowercase u on your keyboard. That's a special character. So when you use it in WebAssign, it's also on that little shortcut menu. So a not equals looks like that. Negative infinity to -1, union, -1 to positive infinity. If, just a side note, if it had said that x could not equal two numbers, let's say it said it couldn't equal -1 or 0, then the way we write that in interval notation is from negative infinity to the smaller one, which in this case would be -1, union the smaller to the bigger, which would be from -1 to 0, union the bigger to positive infinity. So if I get a not equals of more than 1, that's how we write it out. Negative infinity to smaller, smaller to bigger, and then bigger to positive infinity. All right, B, which case is happening now I have to restrict? What, there's a square root there, yeah? Can what's underneath be negative? No. So we say that what's underneath has to be greater than or equal to 0, and x has to be greater than or equal to -3. So if I'm describing the x values that work, it's from -3 and then bigger than -3, or from -3 with a bracket, because it can include it, to positive infinity. Infinity always gets a parentheses, because it's not a number you can define, right? Like you can't give me infinity dollars. I would love if you could try, but you cannot. So it's not a number that you can actually define. It always gets parentheses, negative and positive infinity. All right, we go to C. Now what's happening? Square root in the denominator. So what's the restriction here? Good. What's underneath the root has to be greater than 0 because it no longer can include 0. So then x has to be greater than -4, and in interval notation, that means I start at -4, but I can't include it, so it gets a parentheses, and it goes to positive infinity. And then D, what's happening here? Square root in the denominator and square root in the numerator, right? So we say the numerator has to be greater than or equal to 0, and we say the denominator has to be greater than 0. Numerator can be 0, but the bottom cannot. From my numerator, I get the restriction that x has to be greater than or equal to -4. And from my denominator, I get the restriction that x has to be greater than -1/2. Now this is like an and statement, so it has to be true for both. Sometimes it's easier to visualize these on a number line. If you can see what I'm talking about without doing it, that's fine too. But if it's confusing, then my advice is to draw this on a number line. If I said x had to be greater than -4, then it'd be from -4, greater than or equal to, with a bracket pointing to the right. That would be from my numerator. If I said it had to be greater than -1/2, then I'd have a -1/2, and I'd have a parentheses, and it'd be pointing to the right. And the domain restriction is the overlap of these two. So it'd be from -1/2 to positive infinity. It has to be true for both. Yep.
Since the square root can also be pulled out and done over the entire fraction.
What do you mean?
Like
Rationalized?
I'm just saying, like, if you were to, like, manipulate the function in a way where you made it so that the square root is outside of the x plus 4 divided by 2x plus 1, so it's square root the entire thing. And that's the same function. Then it would be possible to have it less than -4 because both would be negative and those negatives would.
You can't cancel. So you're saying, like, if it was this. Is that what you mean?
Yes.
It's still the same restriction because there's still technically a square root in the top and a square root in the bottom.
Okay.
Does that make sense? If you could simplify what was underneath, it'd be different. So like if I could factor something out and get it to cancel out, then it's different. But we don't even do that because that could simplify it, but you've eliminated a restriction. So you do it before you even simplify it. Yeah. So that square root's still on both. Another case that might occur with this is that, like, let's say in your numerator, so let's say I've got a square root in my numerator that says x plus 4, and then in my denominator, I've got an x plus 2. Let's think about what would happen here. So from my numerator, what's the restriction? It'd have to be greater than or equal to -4, right? X would have to be greater than or equal to -4. But my denominator says what? It couldn't be -2. So if I put that on a number line, then it's from -4 bracket to positive infinity, but it can't be -2. So there'd be like a hole or an open dot at -2. And that means that when I write this in interval notation, I can go from -4 to -2 with a parentheses on the -2 because it can't include the -2, and then start back at the -2 and go to positive infinity. So there can be an overlap that way. If one restricts it in a different way, you've got to make sure like you could skip it like that, or the overlap might shrink it, whatever it is. I think when it gets complicated like that, it's better to draw it on the number line and see it, but you can also do that in your head if you know what you're doing. Questions on domain? Okay. Then we get to something called difference quotient, and this is like one of those things that's a level playing field. Nobody's seen this before, okay? And the first time I do it, you're gonna be like, what the heck? And then it's really not that bad. It's the same process over and over again, okay? The difference quotient is this. This has to get memorized. F of x plus h minus f of x over h. And if we break this into parts, the first thing we're going to do is find f of x plus h. So it's going to give you an f of x. And in that, you're going to take the x plus h and you're going to plug it in everywhere there's an x and you're going to simplify it. That's the first step. Then from whatever you get from that, you're going to subtract your original f of x. So then I subtract the original function from it, which means change my signs, combine like terms, simplify. And then the third step is going to be taking everything that you just got and putting it over h and canceling out the h's, because you will be able to simplify, because there should be an h on all the values that are left, and you'll be able to simplify it. I would say the trickiest part of this, obviously, first is figuring out what you have to do from the beginning. But once you figure that out, people are usually okay, is watching your signs. Be really careful with your signs because there's a lot of steps, so it's easy to make a mistake. All right, we're going to break it down. So example 7, evaluate the difference quotient given x squared minus 2x minus 5. So the first thing I'm going to do is rewrite the difference quotient so it helps me remember it. F of x plus h minus f of x all over h. It's going to get given to you in the instructions on WebAssign. It would not be given to you on your test. First thing I'm going to do is find f of x plus h. So I'm doing this part of my function. To do that, I'm going to take the x plus h. I'm going to plug it into the x values of my f of x. So I get x plus h squared minus 2 times x plus h minus 5. So I took my x plus h. I'm plugging it in place of the x. You with me so far? Okay. Now we're going to do this a bunch. Like x plus h squared is going to happen a lot of times. So you can memorize what that is expanded. You could use your shortcut, or you have to go back to your roots and FOIL it out. At least if you use your shortcut, you'd know it's the first one squared, the last one squared, and then double the product. So it'd be a positive 2xh. You also can literally memorize that because you're going to do it several times. X squared plus 2xh plus h squared. Then I distribute the -2, so minus 2x minus 2h, and then I don't forget about that minus 5 at the end. That whole thing is f of x plus h. There's no terms to combine. Then I'm going to take from that and I'm going to subtract my initial function, which is this, x squared minus 2x minus 5. So I'm going to say minus x squared minus 2x minus 5. And I put the parentheses to remind myself to distribute that, but you can also distribute in that step. Like once you get more comfortable, you could just change the signs then. So if I rewrite that, I got x squared plus 2xh plus h squared minus 2x minus 2h minus 5 minus x squared plus 2x plus 5. Now, if you did it correctly, everything that doesn't have an h should cancel out. I have a positive x squared and a negative x squared. I have a positive or negative 2x and a positive 2x. And I have a negative 5 and a positive 5. Again, if you've done it correctly, every term that's left should have an h on it. So I get 2xh plus h squared minus 2h. And the last step is put it all over h. And then the h's cancel into each term. And what's left is 2x plus h minus 2. Super fun, right? Questions? You try. Oh, all right, let's figure it out. All right, first thing, so listen, I'm going to tell you, this is one of those processes that the more comfortable you get at it, the quicker you are in the like steps you can skip kind of a thing. So if I'm going to again do f of x plus h first. So I'm going to do 3 times x plus h squared plus 3 times x plus h minus 2. And I know x plus h squared already is x squared plus 2xh plus h squared. I'm going to distribute this 3 plus 3x plus 3h minus 2. I will tell you that the people who memorize this, the biggest mistake they make is forgetting the 2 on the xh. Don't do that, okay? Then I distribute. So I get 3x squared plus 6xh plus 3h squared plus 3x plus 3h minus 2. And that is part 1. Now, the next part is to subtract this whole thing. So instead of doing minus and the parentheses, I'm just going to change the signs. So minus 3x squared minus 3x plus 2. Be careful with that because, again, people will write the wrong signs. Now, 3x squared, negative 3x squared cancels out. I've got a positive 3x and a negative 3x, and I've got a negative 2 and a positive 2. Only thing left has an h, 6xh plus 3h squared plus 3h, and it all goes over h. And then I cancel out, and I get 6x plus 3h plus 3. Raise your hand if you got it right. Okay, good. I would say if mistakes are made, like usually by the time when we get around test time, you know this so well that if mistakes are made, very rarely nobody knows what they're doing. It happens, but very rarely. It would be in the signs. So just be really, really careful. You don't need to. Yep, you can leave it just how it is. All right, so listen. Listen. On WebAssign, they don't have a squared one. They have 1 to the first power and they have 1 to the third power. But I added it into the Canvas assignment itself. I added on one that's quadratic, okay? So make sure you add that to your homework. When you go to the WebAssign question, there is one that says like x to the third plus whatever 2x, something like that. Which means when you plug in your f of x, it's x plus h to the third plus 2x plus h, okay? Do this carefully. I would say there is a shortcut for cubes, but nobody ever remembers it. So I would use the shortcut for the squares and then multiply it times x plus h. I feel like that saves you a little bit of time. But be really careful with this question because there's a lot of steps. There's a lot of ways to make, a lot of opportunities to make a mistake, okay? And then get super frustrated. Don't allow it to happen. So if you did, like if you started the homework yesterday, then you're just finishing out what's left. There shouldn't be too many. If you didn't start it yesterday, then obviously you've got that full assignment. Don't forget to add on that the difference quotient one that's on the body of the Canvas assignment. I don't care where you add it, but you got to make sure you add it.